Hi, everybody. In this segment, we're going to dive deep into our AI and machine learning features for classification, empowering you to quickly build predictive models for churn prediction. My name is Jesse Felix. I'm a product manager here at Snowflake, and I'm joined today by Boshin Yang. Boshin?
Hi everyone, this is Boshin. I'm a software engineer in Snowflake. Today I'm going to show you a demo about Snowflake AI and ML capabilities, how we're able to build a churn prediction model end to end.
Thank you, Boshin. And before we get into the details of the demo, we're going to dive deep into the different capabilities in our Gen AI and ML platform. Powering the capabilities that we talk about today, Snowflake built a unified platform for generative AI and machine learning within Snowflake. And today, all within Snowflake, you can easily build and productionalize AI and ML projects without needing to move your data. You can turbocharge your teams who can instantly use AI managed services using simple SQL and no code interfaces, and protect your IP by extending governance and granular access controls from the data models without any complexity. The features that we build are grounded on three simple tenets that are table stakes for our customers. First, customers want state of the art AI and ML capabilities that can operate on Snowflake massive scale. Customers want our models to be efficient. Second, customers want each of our capabilities we build to be fully managed and integrated within Snowflake and easily accessible. Customers want our features to be easy to use. And third, customers want the benefits of the trusted industry leading security and unified data governance that Snowflake provides. Importantly, the features that we build are also grounded on the problems that you are trying to solve for your business. And in fact, one of the top use cases that our customers asked us to help simplify for them involves classification tasks. Specifically, customers want to categorize some form of text into a predefined label that is then used as a feature in a binary classification model, say for a churn or a buy prediction model. The problem with traditional processes for classification is that they're often slow, resource intensive, and error prone as they heavily rely on human labeling. Additionally, customers told us that they want to operate on millions of records that traditional methods of classification are not built to handle. To help customers easily categorize text into predefined labels, we built Cortex AI classified text function. With classified text, you can quickly label text records without any need of any prompt engineering whatsoever. All that you need to do is define the labels that are relevant for your business and point to a column with text data that needs to be classified. It's really that easy. Classified text is optimized to deliver state of the art accuracy for text classification tasks. And because our data engineers told us that they want to easily integrate the results into their data workflows, it consistently outputs results in JSON. Then, to help customers build predictive models for churn prediction, buy prediction, or let's say credit card fraud detection, we built the machine learning classification function. The machine learning classification function enables analysts and data scientists to quickly classify certain data points as having a higher propensity for specific outcomes for things like conversion or, say, attrition. As an example, you can classify customers having a higher likelihood to convert to full-time customers or classify customers as having a higher likelihood of exiting your service. And in the same way that classified text abstracts away the complexity of working with an AI model, the machine learning classification function abstracts away the complexity of working with different machine learning frameworks and algorithms for categorical prediction. I'll hand over the stage to Boshin, who's going to walk us through a demo showcasing how you can use classified text and machine learning classification to build a predictive churn model. Boshin?
Thank you, Jesse. For this demo, I will be working at a ski gear company called Ski Gear Co. Our team at Ski Gear Co. wants to predict customer churns and then try to retain our high-value customers who are likely to churn with some marketing campaigns. We're going to tackle this churn prediction problem in following steps. In the first step, we're going to classify our online customer reviews into satisfied, unsatisfied, neutral labels. To do this, we're going to use Snowflake's Cortex function called classify text to perform this text classification task. In the second step, we will use the labels of these online customer reviews to generate some additional features for our churn prediction model. These new features we're going to generate are number of satisfied reviews, number of unsatisfied reviews, and number of neutral reviews from each customer. Then in the third step, we will start training our customer churn prediction model with Snowflake ML classification capability. We'll also use the trained model to run latest customer churn predictions and create automated alerts on potential high-value customer churns so that our team at Ski Gear Co. will receive these alerts and then start targeting these churning customers with our retention marketing campaigns. All right, now let's get these steps running end-to-end on Snowflake in a Snowflake notebook. In the first step, we're going to classify our online customer review with Snowflake Cortex Classify Text function. Before that, I already pre-populated our online customer reviews called Customer Product Review train in the Snowflake table. In this table, I have the customer ID as well as the text column review, which is our online customer review. Now to use Snowflake Classify Text function, I will need to call this Classify Text function and give it input of this review text column, as well as the list of labels I want the function to output. So here I'm giving the function labels of satisfied, unsatisfied, and neutral. To save time, I already pre-populated the classification results into a table called Customer Product Review Classified. And here is the result that Snowflake's text classification function is able to give me. So this additional classification column is the function output. And we're able to see these customer reviews being labeled as one of these three given labels. Now, going into step 2, we're going to process these customer review labels and use them as additional churn prediction features. Again, I've pre-populated some structured data table as our churn prediction training data features to begin with. Some example features I already have in this table are gender of our customer. Another example is, does the customer have online membership with us, as well as their monthly spend and total spend on our platform. I also have this churn target column in the training data table because these are our historical data and we already know if this customer is churned or not. Similarly, I also have pre-populated prediction dataset, which reflects the most latest value of these features, but we don't have a churn column here. We don't know yet whether these customers are churned or not. This is for our churn prediction model to figure out in just a bit. Now let's add some additional features to this training table. So to do this, I'm going to process the text classification output table a bit by populating number of satisfied reviews, unsatisfied reviews, and neutral reviews from each customer ID and add them into the churn prediction training data table. So these are the 3 additional columns we added. And now we have this final training dataset table called Customer Churn Train with Reviews. Taking a look at this table, we have our original churn prediction features along with our additional features populated from text classification results. We're going to do the exact same thing for our prediction dataset. So here we are adding, again, these 3 columns into the original prediction dataset and populate the final prediction dataset called Customer Churn Predict with Reviews. So here we have our additional review-related columns here. So now that I have both my training dataset and prediction dataset ready, we can start train a customer churn prediction model with Snowflake ML classification. Recall that our training dataset is in this table, and we have a example view of what we just got from step 2. Now we're going to ask Snowflake to start a training job for us. To start this training job, I am running a create statement to create a Snowflake ML classification model that I named to be churn prediction model. This training call takes an input of the training dataset table, as well as a target column name, which tells Snowflake which column in this training dataset table is the target column. Because this churn column is a Boolean column, it's true or false, so Snowflake automatically knows that we're going to run a binary classification model training job here. So now I just have my churn prediction model successfully created. I can start explore this model a little bit. Snowflake does provide a lot of very helpful helper functions for me to explore the model. One example is show training logs. So show training logs is an API you can call for any Snowflake classification model that's trained. And what this API will give me is potentially some warning or error messages that Snowflake encountered while training my classification model. In this case, this function call returns empty, which is a good news for me. This means that my training job was completed just now with no errors. I can also use Snowflake's out-of-box capability to understand the feature importance of the churn prediction model. So by calling show feature importance function from my model, Snowflake will give me a list of my features along with the importance score ordered by importance. And here I will get a better understanding of which features contributes to the customer churning behavior the most. And for example, in this case, I'm able to see that monthly spend, total spend are what contribute most to customer churning behavior. Another very useful set of feature is the evaluation metrics. For classification model, Snowflake offer a lot of different evaluation metrics APIs, like show evaluation metrics, show confusion metrics, and show global evaluation metrics. All of these APIs together covered majority of the classification model evaluation metrics that a citizen data scientist will be looking for. We're going to run the show global evaluation metrics just as a quick example for this demo to show an output. So in this table, for example, we have the recall, AUC, F1 score, log loss metrics. After exploring the model behavior in a little bit, now we can build confidence of the model accuracy and then start running our prediction job on the just trained model. Another quick recall of our prediction dataset we just populated in previous step. So here we have a table of all these features. To run the prediction, I'm going to call this predict function from the churn prediction model and give it input of a JSON object which contains the key value pairs of all the features, which is derived from this customer churn prediction with reviews table. Optionally, Snowflake allows us to configure some optional behaviors. In this example, we configured on-error behavior to be skip. What this means is that Snowflake will skip a row and continue to process other rows in this batch prediction call in case a single row has an error and not able to perform or complete the prediction task. So now we have the prediction results populated and displayed on the screen. I did output both the prediction features and the prediction results. Let's take a quick look at the prediction results on the screen. For each row, Snowflake outputs a JSON object representing the prediction results. The JSON object contains a class field which indicates the identified label for this row. In this case, it will be true or false, meaning is the customer going to be churned or not, along with the breakdown of probabilities assigned to each label. There will also be some optional logs, which indicates some error info or warning logs that Snowflake generated from the prediction process. Similarly, if the prediction result is true, the class will return true and with a breakdown of probability for true or false. All right. So now I get a training and prediction call running on Snowflake end to end. We could start to automate this entire workflow by creating automated alerts on potential high-value customer churns so that Snowflake can send our Ski Gear colleagues emails alerting this behavior and allow us to act on it. What I've done already before the demo is that I already created an alert called Alert Customer Churn that will periodically run on the prediction table, which is also periodically refreshed with a prediction call. And I want to identify customers that are going to churn, as well as the customers that at the same time has a total spend that's larger than $4,000 in history. So that these are considered our high-value customers, but are still going to churn. If these conditions are satisfied, Snowflake is going to send our team an email indicating that there's high-value customers that are going to churn. When we return back to the slides in just a bit, I'm going to show you an example email I already received from Snowflake previously. So this is the end of our demo. Here's an example of the alerting email I received. I'm going to forward it to my colleagues in Ski Gear Co. for them to start the retention marketing campaign. Now let's recap what we are able to accomplish in this session. Firstly, we're able to turn unstructured data into structured data by classifying online customer reviews into satisfied, unsatisfied, and neutral labels, and then generate additional features for the churn prediction model with these labels. Then, we're able to further turn structured data into actionable business insights by building a customer churn prediction model and create automated alerts on potential customer churns. Now, the Ski Gear Co. company has an end-to-end working system to improve customer retention with the help of Snowflake's AI and ML capabilities. To learn more about these two cool new Snowflake AI and ML capabilities Jesse and I shared today, we've linked the public documentations here on the screen. Recall that these two cool features are ML classification capability allows you to train a classification model. It could be binary or multi-class classification, as well as a Cortex AI text classification model called classified text. So that is the end of our session. Thank you all for joining Jesse and me today.